Okay, let's implement these two functions together. The first function we need to implement is ReLU. And there might be various ways, but one of the simplest way to implement this ReLU function is using the maximum method like this. So between x and 0, it's going to filter the negative values. Pretty simple to implement, right? And hyper tangent uses a lot of exponential function, np exponential x minus np exponential minus x. And we're going to divide this value with this value. This is our 10h function. And from now on, let's implement our perceptron. We're going to use class rather than a function to implement perceptron model. Class perceptron like this. And let's outline the implementation of this perceptron class. We need to have an initializer like this. And another method we need to implement is forward and backward. And we are going to implement a train and evaluate function method as well. Okay, let's start from this initializer. Here, we're going to receive the number of features or the dimension of the input vectors. And we'll store these values as our attribute. Features. And after we figure out the number of features, we can define the weight vector. And we will initialize this value as zeros. Known features, comma 1. And data type is float. And we also need to define the bias. And we'll initialize this bias as zeros and data type as float. And to implement this forward method, it is quite simple. We are going to evaluate the dot product between the input vector and the weight. After that, we are adding the bias. So this is a computation of net input. After that, we need to make a prediction by using this threshold function. If the values are larger than 0, you could use this NP-WHERE method. And here, you can pass 3 values. The first value is the condition. You want to find the places where the values are larger than 0, like this. And the next 2 values are values from which to choose. If this condition is met, then X will be chosen. Otherwise, Y will be chosen. And if you don't specify these 2 values, X and Y, then it will just return a Boolean array and whose elements specify which element satisfy this condition. So if this condition is met, we're going to put 1 otherwise 0. And we'll return prediction. Actually, it has to be predictions. This is going to be the next PPP exercise. And to implement this train, we need to receive the data points and the number of epochs as well. For each epoch, we need to iterate through all the data points. And we need to calculate the errors using our backward function. And by naively pass the input vector to this backward function, would occur some errors. So we need to reshape the input vectors in this format. And we're going to pass the y value. And after calculating the error vector, we're going to reshape this one as 1D vector. And after that, we could add this error vector to our weight. And we're going to add these errors to our bias as well. And for evaluation, we first need to get the predictions. And here it needs to receive X and Y values. And by performing the forward operation, you can get the predictions. And after that, we can calculate the accuracy by calculating which points are the same as the label Y. And we're going to divide this value with the total number of data points. Okay, this is the implementation of other methods. So by looking at other methods, try to implement this backward method. And you can also refer to this MLP learning algorithm to implement this method. Okay, take some time and try to implement that method on your own. And let's meet again in the next video.